Okay, today I'm going to be teaching you about exponential decay functions, and it's very important that you've already watched the lesson before this, which is exponential growth functions. Okay, they're very similar to each other, but in this case, when the b number is less than 1, so between 0 and 1, it's going to be a decay equation, which means it starts big and gets small. Remember, growth started small and went big. Decay is going to start big and get small. Okay? So decay starts big and gets small quickly, but it still never crosses the x-axis, just like the other equation. So the best way to do this is just start doing some examples. So first of all, let me just add a quick little table to this. So we have one. And just like the previous lesson, we're just going to put some numbers in for x and see what the heck happens. So remember, just like yesterday, this is going to be x, and this is going to be 1/2 x. Okay? This one's a little bit harder to do mental mathematics for you. I would probably recommend you use a calculator for this, but this is going to be -2, -1, 0, 1, and 2, right? So this becomes 1/2 to the -2 power. That should be in a parenthesis. Sorry about the sloppiness. This should be 1/2 to the -1 power. This should be 1/2 to 0 power. This will be 1/2 to the 1 power. And this will be 1/2 squared. Okay? Now, this one we got to be careful with. So let me actually do some math for it real quick. I have 1/2 to the -2 power, right? And remember what I told you before. If you have a negative power, then what you want to do is if you flip the fraction upside down, it becomes a positive power. So what happens is this becomes 2/1 squared. If I flip the fraction upside down, the negative power becomes a positive power, and I'm left with 2 squared, which is 4. Hope that makes sense to you. But this first one is 4. I'm going to write it in red so we can see it. That's 4. So I do the same thing again with this one. Flip it upside down, it becomes a positive power, so I get 2/1 to the first power, which is 2. So the second one is 2. And then it gets easy. Half to the 0 power is 1. 1/2 to the 1 is 1/2. And 1/2 to the 2 is 1/4. So there's my numbers, right? Okay. The hard part, guys, the only hard part is these negative powers, what to do with them. Just remember, flip the fraction upside down. Graph these. -2 is 4. So remember, very different from yesterday, right? Because we're starting big first. And then -1 is 2. Going down, isn't it? 0 is 1. Looks linear, but it's not. 1 is 1/2. And 2 is 1/4. So you can see what's happening. It's going to do something like this, right? And I'm going to try to, and do I know how high it goes? If I put a -3 in, I could figure that out, but it's probably going to be 8 in my opinion. So it's going to be probably about here. So you can see what's happening. You're going to get something along the lines of that, right? And it definitely is not going to go back up, so I need to fix that. It's going to get flat, and it's going to get closer and closer to 0 without ever touching 0. Imagine that's a nice smooth curve, okay? And then, just like last night's assignment, you need to write this in the exponential decay formula. That should say decay. Anything that says growth here should say decay. Growth, decay, right? Good. All right, we're good there. Sorry, my student teacher did this last year. In this example, or all I'm going to do is I want it to look like, I want y equals 1/2 x to look like, and that actually should be in a parenthesis. And I should have done that from the beginning. Anyways, 1/2 x needs to look like y equals a times 1 minus r to the t. Now be careful here. Yesterday, it was a growth formula, so this was a plus sign. Today, it's a decay formula, so this is a minus sign. So be careful with that. So just like before, like just fill in the blanks. This is y equals 1/2 to the x. What number does a have to be? Well, if you remember yesterday's lesson, it's a 1. So 1 times 1 minus something to the x power, right? Now this is where you have to be careful. We know that the number is a half. So what I need to do is I need to say 1 minus what number is a half? Well, probably a half. So 1 minus a half is a half, right? 1 minus a half is 1/2, so there's my rate. So my a number is 1, my r number is a half, and my t is x. Oops, equals x. Okay? What's hard about that? 1 minus something made that, not 1 plus, so be careful with it. All right, example 2. In example 2, just like before, we need to make a table. So let me insert a table here. This is going to be x. This is going to be 0.2x, -2, -1, 0, 1, and 2. You can use a calculator for this. This is 0.2 to the -2. This is 0.2 to the -1, 0.2 to the 0, 0.2 to the 1, 0.2 to the 2. All right, so be careful with this. What is 0.2 to the -2 make? Well, let's think about what 0.2 is. It's 2/10 or 1/5. So we're saying 1/5 to the -2, which becomes 5/1 squared, which is 25. That's weird, isn't it? 0.2 to the -2 power is actually 25, but you can check it on a calculator. It actually does work. How did I do that? Negative powers, if you flip the fraction upside down, become positive powers, right? So this becomes 25. That's -1. That's 1/5 to the -1, which becomes 5 if you do the math. This is 1. This is 0.2, and this is 0.04. Not 0.4. Be careful with that. 0.04. Graph those. -2 is way the heck off the graph, isn't it? -1 is 5. 0 is 1. 1 is 0.2. And 2 is 0.4. This is going to be really hard to graph, but it is really crazy vertical. And then it flattens out. I have to really fix that. Right? Something very close to that. All right, then I make it look like this. Y equals a times 1 minus r to the t. So this is y equals, what's in front of this? A 1. So 1 times 1 minus something. 1 minus something makes 0.2. Well, how about 0.8? Yeah? 1 minus 0.8 makes 0.2, right? So here we go. A is 1, R is 0.8, and T is X. Okay? Example 3. I'm actually going to skip example 3 and go directly to example 4. You can actually just strike that out if you want. But I'm going to go down to example 4, and that'll be our last one. Oops. All right, so one more table. Just like before, here's x. Here's 3 times 1/4 x. And this is going to be -2, -1, 0, 1, and 2. So this is 3 times 1/4 to the -2. And like I said before, that needs to be in parentheses. Right? 3 times 1/4 to the -1. 3 times 1/4 to the 0. 3 times 1/4 to the 1. And 3 times 1/4 to the 2. So let's do the math. 1/4 to the -2 really means 4 over 1 squared, right? 1/4 to the -2 is the same as 4 over 1 squared, which is 16. So my first one is 16. 1/4 to the -1 is actually 4. 4 times 3 is 12. 1/4 times 3 is 3/4. 1/4. Ooh, messed that one up. Anyone catch that? 1/4 to the 0 is 1 times 3 is 3. 1/4 times 3 is 3/4. And 1/4 squared is 1/16, so it's 3/16. Graph it. 2 is 16. It's way off the heck off the graph somewhere. 1 is 12, so it's like here. 0 is 3. 1 is 3/4. 2 is 3/16. So let me have some fun with this. It is a crazy vertical, so it's going to start something like this. And then from here, it's going to flatten out. Just like that. Okay? Last step is to write it in standard form. So y equals 1 times, a times 1 minus r to the t. That's an a. Use your imagination. So y equals, the a number has to be 3. 1 minus something. 1 minus something made 1/4. Well, how about 3/4? 1 minus 3/4 makes 1/4, so r is 3/4. So my a number is 3, my r number is 3/4, and my t was x. Okay? There you have it. Exponential decay looks very similar to the exponential growth. The only difference is it starts big and gets small. Exponential growth starts small and gets big, starts big and gets small. You need to recognize those because in the next lesson we're going to be using both of them. Good luck.